Hello everyone, welcome to my channel. Today we are going to perform CFD analysis of a nozzle using Solidworks Flow Simulations. In this tutorial, you will learn how to create flow simulation study using Solidworks Flow Simulation wizard, and you will also learn how to create global mesh and control global mesh and adding velocity boundary conditions, similarly pressure boundary conditions at outlet of nozzles, and evaluate average velocity at nozzle outlet. And you will also learn how to create cut plots for pressure and how to create and animate flow trajectories along with cut plots or surface plots. So keep in touch and till end so that you can learn much more, and subscribe our channel if you are new to here. Thank you. So first of all, download 3D model of this nozzle. This nozzle has an outer boundary and a sphere in middle of it. And we'll perform CFD analysis on this nozzle. The download link has been given in this video descriptions. Add Solidworks Flow Simulation module and wait until it appears in tabs of Solidworks. Go to wizard now, create wizard and name your study, that is Nozzle CFD. Please subscribe our channel. Next, ensure that units are in SI. Next, click fluid flow, and from analysis type, this is internal fluid flow. From liquids, add water as a flowing material, add it, and flow type is laminar and turbulent. Next, leave other conditions default. Yes, we want to create lid. Create this surface, select this surface, and this surface as outlet of nozzle. Define thickness of lids, that is about 0.5 millimeter. You can see that lids has been created now. Okay. Yes, we will want to update and no. Hide the computational domain, hide it. Now assign velocity boundary conditions. Go to boundary conditions, right click, insert conditions, and select inlet velocity as a boundary. Select this surface, right click, and select other. Select inner side and delete first surface that was selected. Input velocity, that is 5 meter per second. So velocity boundary has been assigned. Now again, go to boundary conditions and select pressure, openings, and environment pressure. Select outlet surface of this, right click, select other, select inner side of outlet, delete first one. So this is environment pressure. So we have applied velocity and pressure outlet conditions of our nozzle. Go to display, change transparency level, increase transparency to 2.9. You can see how both velocities has been defined. Our next step is to define global mesh controls. So from global mesh control, increase its mesh level. Select manual type, automatic. Show preview of mesh. You can see when increase mesh level, the density of mesh increases. So we have kept mesh level to 6. Okay. So we have defined global mesh on this nozzle. Now our next step is to define goal. Change transparency level again. Right click on goal. I want to define a surface goal that is the nozzle outlet, and our goal is to evaluate velocity at outlet of nozzle. In extraction, select other, select inner side, delete first one. So we have defined a surface goal. Now run your study. So Solidworks is running these simulations and preparing setup. You can see how changes are occurring during different iterations. Please subscribe our channel and also give your comments so that we can improve our SolidWorks tutorials for you. So our simulation has been completed. Now we will plot flow trajectories for velocities. So from this, select inlet surface of nozzle. And put this value to 100. And from this is the velocity. Okay. You can see how velocities are changing their color. Changing their color means they are changing their values. Animate these flow trajectories. And you can see that maximum velocity at end of nozzle, that is outlet of nozzle, is about 16 meter per second. And we can see how spheres is making a harder for water to flow. Change transparency level to see your visuals more clear. Stop. Now go to edit definitions and decrease number of points or just to increase arrow size. Yes, arrow size has been increased now. It is more visible and decreased number of points. So we can elaborate it more clearly. Animate again and see how water flows over sphere. Our next step is to make a surface plot. Go to surface plot, select this surface of sphere, and we want to see pressure at this sphere. How pressure is changing. So you can see maximum pressure as frontal area of sphere and show flow trajectories along this surface plot and animate flow trajectories. Okay, just hide the nozzles. Yes, so it is more clear now. Play animation now, so it is more realistic and you can understand how pressure and velocity values. These are pressure, this is velocity. We can change it from here, velocity to pressure. Okay, so these are the pressure flow lines. Now again we can change it to velocity. Okay, so we have plotted velocity flow line. Now it's time to make cut plots. Go to cut plots, select front plane. Okay, you can see these are the pressure cut plots, and you can see how pressures is decreasing. You can convert it into velocity cut plots. This is the velocity cut plot. So velocity is about 0 at sphere. You can show both velocity cut plots or cut plots and flow trajectories. Here is the surface goal, global goal, that was the average velocity. Show it. You can see the average velocity at the nozzle outlet is about 16.168 meter per second. Please subscribe our channel and give your comments to this SolidWorks Flow simulation.